Recording in progress.
All right, so to start off with our bell ringer, we have radicals, specifically square roots. So you may know what the square root of 169 is. All right, so very small, very small. It's not half. Remember, that's half. That's something times 2 or divided by 2. Square root is you're thinking about something times itself. So if you think about, and just for those of y'all coming in, I am recording. I know it's nasty outside. All right, so think of your perfect squares, right? What's 2 times 2? 4. What's 3 times 3? What's 4 times 4? 5 times 5, right? Okay, what about 10 times 10? 100, right? So all of a sudden we start to get really big. So 169 is actually 13. So 100. It's okay. At least with the video, because they can just skip this part. Well, I am not going to come look at homework because, like I said, I've already started vomiting and I do not want to get close to you guys. So I'm going to stay back here. But at the end of class, I'll try to ask, maybe you can hold it up or something. But let's get into what we need to learn. Wait, there's supposed to be graphs. Do you have graphs? Okay. Okay. All right. So back to our bell ringer with square roots. For those of you that just came in, square roots are the inverse of squared. And 169 is the perfect square of 13. So the square root cancels out the squared, the exponent, and so you are left with 13. So the square root of 169 is 13. All right, what about 120? So let's go back to 10 squared, right? 10 times 10 is 100. Okay, so let's move on to our next whole number. What is 11 times 11? 121. So 120 is not a perfect square. So what we have to do is we have to change. We need to rewrite 120 into an equivalent expression and hopefully be able to find a number that is a perfect square. See if we can pull something out. So we know 4 is a perfect square. And 4 goes into 120 because 4 goes into 20. We know that, what else do we have? So then we have 9. Well, 9 does not go into 120 because 1 plus 2 is 3 and 9 doesn't go into 3. Let's see here. So then we had, what's the next one? 9, 16. 16 is not going to go into it. So let's go with 4. I think that's probably our safe bet. So inside, so in this case, you can treat the square root as, or the radical as a grouping symbol. And we can rewrite 120 as 4 times 30. Okay. I know, I'm sorry. Okay, so it might have been a hot minute since y'all saw this. So the 4, and you can't do this when you add numbers, but you can do this when you multiply numbers. So let me rewrite this. I'm going to rewrite this as 4 times 30. Excuse me. And we know that 4 is the square root of 2, or it's perfect square of 2. And so the square root, sorry, y'all just write this as a go. Even if you don't understand, just write it as a go so you have it as an example. It should help you later. So this is the square root of 2 squared times the square root of 30. And the square root cancels out the square on the 2. So that becomes a whole 2, square root 30. And that is the simplified expression of 120 squared. All right, last one. Now, again, you cannot cancel out square root and squared. They are not inverses when you are adding numbers together, because when you're talking about exponents, you're talking about multiplication. And obviously addition is a much smaller operation than multiplication. So what we need to do is we need to simplify, treat it as a grouping symbol, simplify inside, and then see what kind of number we get. If we get a perfect square, if maybe we can pull out something. So what's 4 squared? 16. 3 squared? 9. Okay. Keep your grouping symbol, aka the radical, square root. What's 16 plus 9? 25. Is 25 a perfect square?
Yeah.
What is it? Right, it's the square root of 5 times 5. And so therefore we can now cancel out our square root and our squared. And we get 5.
I understand the first and third one. I just don't know what.
Okay, so if we end up struggling with this whole radical concept as we move, because we're gonna keep seeing these, especially because we're going to be working with the Pythagorean theorem, then we will definitely, I'll do some tutoring sessions just to go over this, because it's not going to take long. It'll click for you guys. It's just been a while. All right, so moving on to the next part. This will be very important to have. So the Pythagorean theorem relates to, or is about, the relationship between the hypotenuse of a right triangle. I should probably designate that. This is a right triangle. And the length of the right triangle and the length of the legs. So, sorry, the length of the hypotenuse versus the length of the legs. So of A, B, and C, I've already marked it. Sorry, I got ahead of myself when I made this, I guess. So C, the long one, represents your hypotenuse. So you can imagine as we are graphing, this should look fairly familiar. You know, when we find slope, when we have a line or a graph and we're finding slope, we take our y, the difference in our y, which is the numerator of our slope, the top number, and we go up or down that many times. And then the denominator is your x-axis. So the A and the B are pretty much like your x and your y to help calculate slope. And C is the graph itself. So this is a way to kind of help us understand slope and the distance. So usually we're going to try to find the distance of the hypotenuse based on the information given about the legs of the right triangle, which is the A and the B. So make sure that you've got like a nice neat representation of the Pythagorean theorem and what I've got here. Because as we move into calculating distance between 2 points, as well as the midpoint of those 2 points, we're going to be using this equation and its derivatives many times. So as we do it, it'll definitely get more familiar. All right, you also have a reminder of the distance formula there at the bottom of that little box that I've got. You've got D equals the absolute value of A minus B. So again, because it's absolute value, it doesn't really matter which number you have as A and which number you have as B. One is going to be one end of the line segment, right? And one is going to be the other, but whether it's negative or positive doesn't matter because we're using absolute value. We just need to know distance, because distance is always positive, no matter what direction it goes in. Okay? Everybody got these? If not, I believe this is simply a copy of what you've got right there on page 93. So you can go there to get it. So really, I want to go through the derivation of the distance formula. Maybe, do I want to? Yeah, well, okay. I kind of already have, right? We understand that if A is the bottom, which it is, A is like that bottom horizontal line, that is representing the difference in X. It's moving left to right. Whereas the B side is your vertical leg, which means it's the difference in the Y. So when you look at this graph, you know, we're looking at the distance between point 1 and point 2, which are the two ends of the hypotenuse. But by calculating A, the difference in X, and B, the difference in Y, we can figure out the difference in the sloped line, the hypotenuse. So the equation, if you don't really understand what I'm going, you don't need to know the derivation. I'm just sort of giving it to you so you have it. And again, this is at the top of page 93. The application of it is we take our Pythagorean theorem, and I just flipped it, c squared equals a squared plus b squared. And I just am replacing my A, B, and C with my A is the difference in X. So that's my absolute, let me just, hold on, keep the same, yeah, whatever. Absolute value of X squared, or for X of 0.2 minus X of 0.1 squared. That's A, plus the difference in Y, which is the absolute value of Y2 minus Y1 squared. Now, we don't need the parentheses because absolute value is a grouping symbol if you've got an operation going on inside it. And also, because anytime you square a negative number, your answer is always going to be what? What's a negative times a negative? Always, right? So you actually don't even need to have that absolute value. You just keep it in parentheses. So your final equation, because we get rid of the distance, we don't want to square the distance. So we have to have our radical, our square root. And so it cancels on D, but it can't cancel on the A and the B because they're being added together. And so the distance of a line segment is the square root of the difference in X squared plus the difference in Y squared. And it's okay. You don't entirely understand what just happened. I just need you to make sure that you've got this equation right here. Oh, yes, it is supposed to be one. Thank you. Oh, I'm sorry. Hold on. Just having a little bout of nausea. Okay, so everybody has this equation. This equation is your lifeline. Because once you have 2 points, you have your X2 and your X1. You have your Y2 and your Y1. You've got the numbers. So having this formula means you just plug them in, simplify, and you've got your distance. So let's look at an example of that. So we are given, find the distance between the two ordered pairs, -4 and 2, and 1 and 7. So again, I've given us, this is our equation. And so I have already gone ahead and labeled my X1, X2, Y1, Y2, because I have to have that. Otherwise I get really confused. And then you just plug those values into your main formula, your distance formula, and solve. So distance equals the square root of X2, which is 1, minus, and here's where you've got to be really careful. Don't make the negatives or the subtractions miraculously disappear, right? Because you have a -4, but you're subtracting a -4. So this is 1 minus -4. I'm just going to use my double parentheses, squared, plus Y2, which is 7, minus Y1, which is 2, squared. All right, So now we just continue to simplify inside our square root. Easy now. There we go. All right, so 1, and also keep your parentheses just in case they're negative, because that reminds you that you're multiplying a negative times a negative. Or, since we know that a negative times a negative is a positive, once you've simplified inside, you could just make it positive because it's going to be positive regardless, right? Everybody understand what I just said? Okay. All right, so this is 1 plus 4, which is 5. So 5 squared plus 7 minus 2, which is 5 squared. And so we know that that simplifies to what? 25 plus 25, because we're adding them. Because 10 squared is what? 100, right? That's okay. We're just making up. Look, I'm not really either. I'm trying not to be in the bathroom throwing up. So I'm really distracted. But think about like, that's a great example of what the mistake that can be made. You could say, oh, this 5 squared plus 5 squared is 10 squared. So I've got 100. So my answer is 10. Yay, I'm done. But it's not. So this way you simplify all the way down, because 5 squared plus 5 squared is 50, not 100. Okay. So this gives me, square root of 50. Now, we know that 50 is 2 times 25. And 25 is a perfect square. So this is, we can't do anything with the 2, but this is 5 squared. So the square root and the 5 squared can cancel each other out. And so this ends up being 5 square root 2. That's our distance. I mean, technically, this is in example 1. It's in your book, but it's nice to have it in your notes, because a lot of times just the process of writing it retains it in your memory. All right, I went ahead and separated this out. Express your answer as a simplified radical, which I gave you, which is 5 square root of 2. Or you can plug that into a calculator. And I wonder if I can. Nope, it's not going to let me. Oh, yeah, it will. Here we go. Calculate, not calendar. I'm sorry, my video kids aren't going to see this, but I'm just going to. No, it's on here. There it is. If you plug in the square root of 50, I'm going to do 50's square root. It gives us 7, around 7.07. Obviously, the square root of numbers that are not perfect squares are what kind of number? You may remember our sets of numbers. Irrational, which means they what? Never end. Ever, ever. Never end, never repeat. Okay, so just round this off. Usually the safest place to round it off is round it off to around the hundredths place. So we would round this to approximately, just make sure you got your approximate sign, approximately 7.07. Same thing as, but 5.5 times the square, 5 square root 2 is your perfect answer. The 7.07 is approximate. Okay. All right, so let's look at the midpoint formula. The midpoint formula, I have given you the derivative. You have that in your book. But let's just go and look at the formula. I feel like I'm going to absolutely overwhelm you guys. Here's your midpoint formula. Midpoint formula is M. It's just an ordered pair, right? Because the midpoint is just that one little point in the middle of a line segment. So it's the average of your X values of the 2 endpoints. That's the X. And the average of the Y values of the 2 endpoints is your Y. That's all this is, right? It's just the average. So X1 plus X2, if you wanted to do X2 plus X1, go for it. Same answer. Right? Okay, we good? Okay. Let's use the midpoint formula. Example 2, find the midpoint of the line segment with endpoints at -3, 4, and 1, 9. So again, all you do is I've got the formula written here for the midpoint. It's just the average of your x's and the average of your y's as your x and y coordinates. And then you substitute. So x1 is, I'm gonna make -3. Y1 is 4. X2 is 1 and Y2 is 9. And I have seen these get mixed up. I have seen people randomly put X1 is -3 and Y1 is 9. I don't know, just use these, keep these examples neat. And so you can go, wait a minute, how do I pick which one? And look at what you did here and you'll be good. Okay, so let's go ahead and plug it in and then solve. So the midpoint is my X1, which is -3, plus X2, which is 1, divided by 2. And Y1, which is 4, plus 9 over 2. What's -3 plus 1? -2 over 2. 4 plus 9 is 13. Yeah, that's just me. All right, so the only one I would probably simplify, I don't know. For ordered pairs, it probably is nice to have a mixed number because it gives you a better idea of like where your whole number, what two whole numbers it's in between. But -2 over 2 is -1. So we know our x point is -1. Our y, 2 goes into 13 6 times with 1 left over. So it's 6.5. And there's our midpoint. Easy enough, right? Come on in. No? Is somebody standing there? Who was it? Oh, that's possible. All right, everybody got this? Are we good? I'm moving. Slope intercept form. What is the slope intercept form? Anybody?
Okay. It's y equals mx plus b.
There we go. And what does the M stand for? And well, you better stop. Okay, there's a reason. Look, there's a reason why I used a capital M for midpoint and a lowercase m for slope, because that M is not your midpoint, that's your slope. I'm glad you said that. I did want to distinguish between those two. There is a reason one is capital and one is lowercase. Okay, B is what? Did somebody say earlier? What does the B stand for? Anybody besides Genevieve? She's already getting 100 on her work ethic.
Bro,
She's working. It's your y-intercept. Thank you.
she got 1 out of 7 right here.
Well, I tried.
For today, yeah. Participation's part of it. Hey, participation will save you if you did not have time to do your homework, right? Like it's participation, classwork, homework. It's a combination of all those things. Okay, distracting does not count as participating. Okay, so write the slope intercept form of the equation of the perpendicular bisector of the segment in example 2. Okay, so my 11th graders, we're gonna need your help right now. We got, let's see, I think in your book, yes. Okay, so in your book on page 94, did I put it? Let me just check. Okay, I did not. In your book on page 94, example 3, excuse me, you have a graph that shows you what we're talking about here. I'm going to kind of recreate it, but I'm not going to do it on graph and try to make it perfect. Okay, so this was our line segment from example 2 above, where we had point -34 and we had 0.19 and we were finding the midpoint. Okay, so the midpoint was right here, which we calculated. This was M. A perpendicular, what does perpendicular mean? Yes, creates 90 degrees angle on both sides of the intersection. So it goes like directly through our line segment. So it's perpendicular. which is very helpful because we have a way to determine the slope of perpendicular lines. Stay awake, guys, you need this. And what does so perpendicular means it goes, like creates a 90-degree angle, and we know what to do with slopes of perpendicular lines. Okay, bisector. My geometry students from last year, what does bisector mean? And actually, y'all can look at this graph and tell me, bisector.
Oh, it goes
Say-
through and creates
Right? So it's where the lines intersect, but where on the original segment do the lines intersect? At the
Yes, okay, I
midpoint,
remember what it was.
right? A bisector means that it sections off that line segment in the exact middle. So both sides are exactly the same length. Both sides, right? Okay, so bisector means that it intersects at the midpoint. I don't know. Oh, I'll try to put that here. Intersects, internet, this rain's killing the internet connection. Intersects at the midpoint, which tells you something about the two line segments. Oh gosh, there's the nausea again. Hold on. Those two line segments are equal or congruent. Dun, dun, dun. Sorry, I didn't mean to cause anxiety. But they're exactly the same length because that's the definition of a midpoint. Okay, so we want the slope intercept form of the equation of the perpendicular bisector of this segment in example 2. What that means is we know the slope, or we can determine the slope because it is the opposite reciprocal of our previous line. But we also know a point that exists on our perpendicular bisector. What is that point? What the dotted line I've created. What point do we know, have we calculated, that exists on that line? The midpoint, yes. Okay, so find the slope of the segment. So what we have to do is we have to go back to our previous example, but I have the points written here, right? We have 2 points. If we have 2 points, we can calculate our slope. What's the slope equation? Ish. Yeah. It's it's your rise over your run. So it's the difference in your y. So y2 minus y1 over x2 minus x1. I'm going to use my -3,4 as my 2. So this is -3. Nope, that's not y. This is why I label them. So the x's are -3 minus 9, and the y's are 4 minus 1. Nope. What did I do? See, I told you this is why I have to label them. Let me just label them. X1, Y1. That is my 1 and my 9. X2, Y2. It's bigger. That is my -3 and 4. Okay, now I think I can do it. 4 minus 9 over -3 minus 1. Okay. Okay, so 4 minus 9, -5. -3 minus 4, -4. But let's make it positive. 5/4. Okay, so again, that's the slope of my original line segment, the solid line from example 2. So what's its opposite reciprocal? There we go. There we go. Noah started it. Who was that? Genevieve finished it. Teamwork, right? Teamwork makes the dream work. Don't worry, I'll never say that again. All right, so the slope of our perpendicular bisector is the opposite reciprocal. So it's negative, whereas our other one's positive. And then we just flip the fraction and we've got -4/5. So now we know our slope, which was step 2. So yay. That already gets that. So first step, find the slope of the original segment. Step 2, convert the slope to its opposite reciprocal. So we get the slope of the perpendicular bisector, which is what we're being asked to graph. And then we use the perpendicular bisector M perpendicular, whatever. No, and the midpoint calculated in example 2 with the point slope form and simplifies. Anybody remember the point slope form? Wasn't it? Yes, there it is. Thank you. Brianna's got it. So y minus y1 equals, isn't it the slope times the difference in x? M times x minus x1. All right, and the midpoint is just a point. So that gives us our x and y. So the midpoint was what? I don't want to scroll up. It was the -1 and 6.5. Yeah, that's gonna get a little, I probably should keep that as an improper fraction. Oh, yeah, it is gonna get a little ugly. All right, but that's my x and my y. X1, y1. And then my slope is, yeah, I'm gonna keep that 13/2. And then my slope, so that's my midpoint. And then my slope is -4/5. All right, so now we can plug it in and we'll get our slope intercept form. So y minus y1, which is 13/2, equals -4/5 times x minus a -1. Yeah, it's not very nice. That's okay. It's just fractions. All right. Shut up, Ms. Bond. Don't ever say that again. Let's see. Hopefully I gave myself enough room. Y minus 13/2 equals, I'm going to go ahead and distribute. So we know that when we subtract a negative, it becomes what? Positive. So this is just -4/5 x plus, well, sorry, -4/5, because a negative times a positive is a negative. So we'll just keep it negative. Okay. So at this point, all we have to do, we have our slope and our x, we have y equals. So all we have to do is just add 13/2 to both sides. And now we have to find our common denominator. So this is 10. So that's going to be 5 times 2. So that's 8/10, -8/10 plus, oh my gosh, 5 times 13 is 65 over 10. All right, so 65 minus 8 is 57? 57/10. There's our y-intercept. So, sorry, I ran out of room. This is messy. Y equals, what's my slope? -4/5 times x. Look, the slope never changed, and our point slope form just proved that. We were just using it to find, essentially just find our y-intercept. So plus 50. Yeah, there we go. 57 over 10. And there we go, we're done. It was only ugly because of the fractions, right? If you had nice, neat whole numbers, that would have been super easy. Y'all know this. Unless you feel like you're gonna. All right. My last note from this section is looking at the distance formula from 2 points in space. So far, we have been working on a plane. And a plane is two-dimensional. It's flat, like a piece of paper. So now we want to think of this in terms of three-dimensional or cubed. So you have y, which is up and down. You have x, which is left and right. And then you have z, which is in space, third dimensional. So think about your tabletop as your plane. And then if you hold your pencil with one end on the table, the other end sticking up in the air, what is the distance between maybe where your paper is, the corner of your paper or your book on your desk, and the tip of your pencil? That is what we're looking at. We're looking at something in a three-dimensional space. So when that's the case, we have our points have three coordinates. We have the x coordinate, the y coordinate, and the z coordinate. And we have our distance formula simply just tacks on that z coordinate, the difference of that z coordinate squared to the end, and then calculate with it. So the distance formula, I've highlighted here, the distance formula for 2 points in space is d equals the square root of the difference in x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. It's just adding that third coordinate. Midpoint, it's the same thing. It's adding that third coordinate. I am not going to walk y'all through the derivative of it. All you need to know is that these formulas will work if you have them as a reference. So I'll let you guys get those copied. They are on page 94, but they're sort of lost in paragraphs, which is not very nice. So I wanted to kind of separate that out for you. So we'll do an example with these. And then I think we should be good to go. All right, everybody got them?
I'm almost done.
Okay. I'm trying so hard. If not, I'll be like, everybody plug your ears and hum.
Oh, you don't.
Yeah, I don't need a group vomit session. Oh, don't make me laugh. Don't. Oh, it burns. It was the most stressful drive back to my house to get Victor those shorts because I started feeling sick right as I was driving. I was like, oh no.
Are you gonna go through with your last two classes?
I don't know. They're trying. I told him if I can hold it together, that I'll stay. Y'all can teach yourselves
You don't have to make yourself stop.
how to do your English stuff. Okay. Oh, sorry, I did cover it up. Everybody good? Oh, well, here's the formulas again. I've got them right here for the problem. Let's look at an example. So when you have a point that exists in space, because it has to have three different coordinates, it's not an ordered pair, it's an ordered what? Triplet? Triple? I don't know. But it's got three, yeah, trio. There we go. It's an ordered trio, not a love triangle. I don't know how much we're gonna love these. Okay, so they've asked us to find the distance, which is just the length, and the midpoint of the segment with the endpoints at 2, -1, 3, and 3, 5, -1. So all we're gonna do is define our X, and I don't know, I'll make it green so it kind of stands out. X1, Y1, Z1. You know me, I've got to label them or I'll always get them mixed up. X2, Y2, Z2. And that, my friends, is why I put a line through my Z, because my Z's and my 2's look so similar. All right, so X1 is, I'm going to make that my 2, a -1, and a 3. 0.2 is 3, 5, -1. Uh-oh, I think they've released the hounds upstairs. There we go. Okay, so X2 is 3 minus X1, which is 2, and we're squaring that. Y2 is 5 minus a -1, which is, so I'm gonna change that to a positive. Over there. And then we have -1 plus, no, sorry, excuse me, minus 3 squared. It's exactly the same. All you do is you add that third coordinate, square it, add them together, just more, right? It's the same, but different, but still the same process. So we have 3 minus 2 is 1 squared. 5 plus 1 is 6, right? It's just 1. And then -1 minus 3 is -4, but we're squaring it. So I'm just going to make it positive 4, right? We good? Because it's going to be positive no matter what. Yes. So 1 plus 36 plus 16 is 53. Just ugly. We're just going to leave it. We're going to leave it right there. I'm pretty sure 53 is a prime number, so there's no way we can simplify that. Is it time? Okay, we're going to work on the homework. Yeah, it is. We're going to work on the homework for the section tomorrow. I might be doing it via Zoom, or I'll make a video, and y'all get to watch it and follow along. Sorry.
Yes. No, she's gonna be here, but she's gonna Zoom call from there. Yeah. And I said, oh, does that mean you're not gonna be here?
I will
She's gonna
probably.
Zoom call from the desk.
Yeah.
Well, honestly, she always reminds me of the Russian